Alright, video for you here that has the solutions to 2009 A-B test from Form B, number 1. It's calculator active. At a certain height, tree trunk has a circular cross-section. The radius of that cross-section grows at a rate modeled by the function dr dt equals this centimeters per year. Okay? For times 0 to 3, I guess that's 0 to 3 years, where time is measured in years. At time t equals 0, the radius is 6 centimeters. The area of the cross-section at time t is denoted by that. Okay. Write an expression involving an integral for the radius for that, and then use that expression. Well, I have dr dt, so if I want to get back to r, then I have to take the antiderivative of that, right? So remember that integral of rate is equal to change in stuff. And what am I talking about? Stuff is whatever the rate is modeling here, the stuff that's changing here. The key things here is understanding that you have to set up the integral, and also that the change in stuff doesn't necessarily tell you the total amount of stuff, because here at time 0 it was already 6 centimeters. So this is the fundamental mistake of calculus, is to forget about that. So if I want to know an expression for what the radius is, then I need the change in the amount of stuff from 0 to time t of this 1/16 3 plus sine of, I don't know what the College Board does about this if you put a t squared there. And we already used the t here, so technically that's a correct use of the word technically there. You're supposed to change that to some other letter. Usually we just go back to x, because you already use the t to be the variable here. But it's just really like a what's in a name kind of situation. So if you put that as t squared dt, I don't know what they do with that. If they dock you a point, it would be hard for me to imagine they could justify taking a whole point off for that. But technically it should be that. And then, so this is the change in the radius here. And it started at time 0, the radius was 6. So don't forget that. Otherwise, like if you plugged 0 into your radius function, then the area from 0 to 0 would obviously be nothing, and then you'd have nothing here, so you'd have no tree. That's no good. And then what do they want us to do? They want us to find what is the radius at 3. So now that I have a number there instead of a t, I can, if I want to, go back to writing t here. You could still write it as x. It doesn't matter, because it's not getting used in another way there. Alright, this is a calculator problem, and this is not an integral that you could evaluate anyway. So I'm going to go to Math 9, 0 to 3 of 1/16. I could have put the 1/16 on the outside because it's a constant, but it doesn't matter. 1/16 times 3 plus sine of t squared dt, and then to add the 6. Now, College Board wants our answers to be rounded to 3 decimal places correctly, so 6.61 and then a 1. And that would be in centimeters. All right. Part B. Find the rate at which the cross-sectional area is increasing at time t equals 3. Indicate units of measure. Well, what the area, if it's circular, the area of a circle is pi r squared. So the area as a function of time would be pi times r squared. And this is r, right? This whole thing. You could rewrite that whole thing in there, but I'm not going to do that right now because I have it right here. And so now I need to take the derivative of that because they want the rate at which the cross-sectional area is increasing, so that's the derivative. Okay, so let's see. I need to find the derivative of this, and that's going to definitely involve the chain rule. So the derivative of pi times something squared, move the exponent out to the front, that's 2 pi times r of t, and then times the derivative of what's inside. Right? Okay. And they want us to find that at 3. So a prime of 3 is equal to 2 times pi times r of 3. We actually already found that right there. And then r prime of t. R prime is this right here. So let's see. Let me just do that in my calculator real quick. I didn't make sure I'm in radian mode before I did that sine function. I should have done that. Always check. So 1/16 times 3 plus sine of t squared. So I'm plugging 3 into this, so that would be 9, is equal to 0.213. So let's see if we can get an answer. So I have this number right here times 6.611 times 2 pi gives me 8.858. Right, and this is the indicate units of measure. This is the rate that the area is changing at. So the area would be measured in square centimeters. Right? Area is always square units, and this problem is centimeters is our measurement of length, and the time is measured in years. So 8.858 square centimeters per year. All right, part C. Evaluate this integral here. Using appropriate units, interpret the meaning of that integral in terms of cross-sectional area. Okay, well, let's do this first, and then we'll think about the units. So this looks like fundamental theorem. I think I might have actually room to squeeze it in right here. So fundamental theorem of calculus, without knowing anything about this problem at all, as if you want to find the integral of a derivative, then, well, let's just, I know what the antiderivative of this derivative is. It's just a. Right? And they want me to actually evaluate that. So I can do that by finding let's see, I've got some work to do here. I got to find a of 3 and a of 0. So to find a of something, I need to do this, right? And this thing here, Oh, I guess this is pretty easy to do because I think I already have the numbers, don't I? So let's see. So the area at time 3, plugging 3 into this, is pi times r of 3 squared. But I have r of 3 here. Okay, so that area, the first thing here, area 3 is, at 3 is pi times 6.611 squared. And that's 137.304 minus the area at time 0. Remember the radius at time 0 is 6. They told us that. So that's 36 pi, right? Pi r squared. And so that number minus 36 pi is 24.207. And the units for that, that's an area minus an area, so that'd be in square centimeters. And so what did we just find here? That's the area at 3 years minus the area at 0. So this is the increase in cross-sectional area from year 0 to year 3. The way that you describe that doesn't have to be exactly the words that I said. It would just have to capture somehow the idea that the area changed from time 0 to time 3 by this much. That's what that means.